All right, let's talk about combining functions. So if f of x is x squared plus 3 and g of x is 2x minus 2, can you find f of x plus g of x? Well, that's simply going to be x squared plus 3 plus 2x minus 4 You can also write this as f plus g of x and the domain is simply going to be the domain of f of x intersection domain of g of x, which in this case is all real numbers. Let's try another. So f of x minus g of x is just x squared plus 3 minus, don't forget to use parentheses because there's more than one term, so we just combine like terms, and again the domain is the intersection of the domain of f and the domain of g. Let's try another. So f of x times g of x is just what you would expect. You just multiply f of x and g of x. And I would go ahead and leave it that way because now it's in factored form and it's easier to tell what's going on with the function when it's factored. And again, the domain is the intersection of the domain of f and the domain of g. Let's try another. F of x divided by g of x is what you would expect. And this can also be written f over g of x. And the domain is the intersection of the domain of f and the domain of g, provided g of x is not equal to 0. So in this case, we just have to find the x such that g of x is not 0. So the domain of f was all real numbers. The domain of g is all real numbers. So our domain is all real numbers, x not equal to 2. Okay, let's talk about composite functions. So let's say you have a pond and x is the temperature of the pond. And g of x is the number of bugs in the pond as a function of the temperature. So let's say the warmer it is, the more bugs there are. And then there's a frog who eats the bugs. So as you imagine, the more bugs there are, the more frogs there will be. So the number of bugs depends on the temperature, and the number of frogs depends on the number of bugs. So if we compose these functions, we have f of g of x, the number of frogs in the pond as a function of the temperature. And if you're wondering where the bugs went, they went into the frog. Now there's a couple of ways of writing it. By the way you say this is f of g of x. And you can also write it as f of g of x. I prefer this way because you can see that the g of x function is inside of the f function more easily. And something you'll learn when you get to calculus is if you were to look at the average rate of change of this composite function for a period of time, it would be the average rate of change of the bugs as a function of temperature times the average rate of change in frogs as a function of bugs. And then the bugs would cancel, so you get frogs over temperature. But that's for calculus. Right now, let's practice composing particular functions. All right, suppose f of x is x squared plus 2 and g of x is 5x minus 3. So you're just going to put 5x minus 3 wherever you see the x. If you want to try that on your own, I would hit pause. So we're just going to get 5x minus 3 squared plus 2. Let's try another. All right, let f of x be x squared minus 4x plus 1, and g of x is 7x plus 3. Can you find f of g of x? So you're just going to put 7x plus 3 wherever you see an x. You want to hit pause and try that one on your own. We're going to get 7x plus 3 squared minus 4 times 7x plus 3 plus 1. And then do you think we'll get the same thing if we go the other way? So you're going to put f of x, or x squared minus 4x plus 1, wherever you see the x and g of x. So I would hit pause and try that one. So it's going to be 7 times x squared minus 4x plus 1 plus 3. So it's easy to see that f of g of x is not the same as g of f of x. And that's generally true, except for certain cases that we'll talk about in the next section. Let's try another. All right, let f of x be sine of x plus x cubed. G of x is 3x plus 1. So you're just going to put 3x plus 1 wherever you see an x. If you want to hit pause and try that one on your own, you get sine of 3x plus 1 plus 3x plus 1 cubed. All right, let's try composition function using graphs. All right, using the graphs, can you find f of g of 2? The graph on the left is g of x. The graph on the right is f of x. I would hit pause and try that one on your own. So first we find g of 2, which is 3. So that means we're going to be finding f of 3. Well, f of 3 is about 8.4. Let's put it approximately equal. And let's try another. Can you find f of g of 6? Again, I would try this on your own. So first we find g of 6, which is 4. So that means we're looking for f of 4. F of 4 is about 7.8. And it's okay if you got a slightly different answer. Let's try another. Can you find g of f of 10? So again, try this one on your own. All right, so first we go on the f graph and find f of 10, which is 3. I'm sorry. And then we find g of 3, which is about 2.6. Let's try another. All right, can you find f of g of 9? So I would hit pause and try that one. All right, so first we find g of 9, which is 7. So we go to f of 7, and that's equal to 5. Let's do one more. Can you find g of f of 5? And it's okay if you get a slightly different answer because there's some estimating involved. I would hit pause and try that one on your own. All right, so we start with the f graph. F of 5 is about 6.8. So we look on the g graph. 6.8 is about here. And g of 6.8 is 5. And I'm going to put an approximately equal sign. And you can see how the errors get multiplied. All right.